Hello friends, this question is from test series number 9, stability signal in system, topic name is jet transform. It's a 2 marks problem. Question says that discrete signal xn whose jet transform is xz is given to you that summation of n to 0 to infinity to raised to n by n plus 2 jet to power 2n, and is orthogonal to the signal. We need to find out the signal which is orthogonal to xn. So if any signal yn want to be the orthogonal to the xn, so it must satisfy the property of summation of n to xn multiply yn conjugate is equal to 0 in case of any complex signal. In case of real signals, the multiplication of xn and yn should be 0, right? So basically what I need to do, I need to find out the xn from this xz. We need to find out the xn, and we need to find out the yn for all these 4 options, and we need to see that which yn, for in case of which yn this property holds true, that multiplication of xn dot yn is equal to 0. So it is if we will see that our xz, so if just vary the value of x, vary the value of n for n is equal to 0, it will be half. For n is equal to 1, it will be 2 by 3 z square, and then z is equal to 4, and then so on. Just if I just take the inverse of it, so it will be half del n plus 2 by 3 del n plus 2, then plus del n plus 4. Okay, and pretty much in each and every even value of n, we can see that we are getting our sequence. So now we can examine any value of yn. Just you can just see that if I have the even value of the n, so I need to find out the sequence which has a values in odd, such that our multiplication should result 0, because in that case we are not going to have any overlap terms. So I can see that in this third term only I can have a odd number of terms, because this term, first option, will have the n even and odd both. This will also have a term even and odd both, because if odd is okay, but if you have a even term, then you will have a finite results, because I want multiplication, right? So a to b is, if any one term is 0, then multiplication is 0. If you already have an even number of terms in xn, so you must be going to have yn which has a odd number of terms, such that your for every value of n, your multiplication is 0. So I think option C is pretty much fine, because option C will result the odd number of 10, 2n plus 1, which is an odd term. So I can verify also by just getting the yz. So yz is nothing but z inverse plus 1 by 16 z minus cube, and up to so on. Just take an inverse of it. So y of n will be del n minus 1 plus 1 by 16 del n minus 3. You can see that my xn is having even term from 0, 2 and 4, 0 minus 2 minus 4, and my yn is 1, 3, 5. So there is no overlap, so the multiplication of xn and yn is going to be 0. So my condition is satisfying. It means that the option C is the correct option, because the y3z is basically an orthogonal signal for my xn. So option C is the correct option, which will be the answer for my question. Thank you.